Write the following rationals in a decimal form using the theorem 1.4. So actually we can say that using the theorem 1.4, that what is 1.4 I am going to tell you without knowing this, and now I am going to tell you the. So 1.4, theorem 1.4, we forget about that. Actually the decimal representation of decimal expansion of a rational number is terminating decimal if the prime factorization of denominator in the form of in the form of 2 to the power of m 5 to the power of m. So the rational number, the decimal expansion of the rational number is terminating decimal if the prime factorization of the denominator is in the form of 2 to the power of m 5 to the power of n. So first we can say that that is the terminating or not. So after that the decimal representation also you can give. Okay, we have to write the decimal form also. First we can say that 13 upon 25, the first question here, 13 upon 25. So 13 upon 5 times 5. So this is in the form of 2 to the power of m pi to the power of n. So we can write this one again, 2 to the power of 0 times 5 to the power of 2. So this is in the form of denominator in the form of 2 to the power of m 5 to the power of n. So therefore it represents, it gives terminating decimal. So what is the decimal form of this one? So now I am going to tell you. It is decimal form means a terminating decimal, you can say. Okay, I will tell you this one and decimal form also. 13 divided by 25. So anyway it gives the terminating decimal. The division ends here. 0 times 0, 13.130. 5 is 125. 5, 50, 2 is. So here the decimal representation of this one is 25 is equal to 0.52. So here also we know that one, if a decimal is terminates, if any given rational number gives the terminating decimal, how many places are there in the decimal part? After how many places, decimal places, that rational number will be terminate. So that also we can see. According to this, you see here also one thing I am going to explain you. The powers of 2 and 5. What are the powers of? Means degrees of are the powers, you can say here. The degrees are powers, and 2's power is here 0 and 5's is 2. Which one is greater? Here 2. Means here whenever the given rational number gives the terminating decimal. In its decimal places, 2 decimal places are there. Here you see it gives the terminating. After 2 decimal places, this division will be ended. So that's in this way also you can easily find out how many decimal places are there in the decimal part of the. Okay. Next second one, 15 by 16. So here this one also first condition is satisfied, 15, 16 are co-primes. In the second here 16 can be written here, 16 equal to 2 to the power 2 times 2 times 2 times 2, it is 2 to the power of 4, and here 5 is not there, here you can write. So you can do prime factorization of 16, prime factorization of 60 is in the form of 2 to the power of m, 5 to the power of n. Therefore, it gives terminating decimal. Terminating decimal. In how many digits, how many steps this one is terminates, means in how many decimal places are there in the decimal part of the quotient. So here you see highest degree is 4 is there. After 4 steps are the 4 places, this rational number will be terminates. So here, so I am going to write that one also here. Check once, we can verify that 15 divided by 16 here, 16 zeros are 0, 15, 150 it is, 16 8s are, 16 9s are, you can write here, 16 9s are 54, 144 here, 660, so 16 2s are, 16 3s are 48, again here 12, 120, 16 7s are 112, 80, 16 5s are 80. So here you see how many places are there here? 4 places are there. Means here we can understand that in how many places this division will be ended according to the maximum power of the prime factorization of the 2's and 5's. So here 2 to the power of 4 is there, and this rational number can give the terminating decimal, and it contains 4 digits in its decimal place. Next, third one. So here third one is 23 upon 2 to the power of 3, 5 to the power of 2. So directly I am going to write, already this one is in the form of 2 to the power of n, 5 to the power of m, and it gives the terminating decimal. So how many places are there in the decimal part? Means 3 decimal places are there here. This division of whenever this one is divided, numerator is divided by denominator, so you can get the decimal number. In this decimal number there are 3 decimal places are there. So division ends with 3 decimal places. 3 decimal places. Okay. So similarly, fourth one, 7218 upon 3 to the power of 2, 5 to the power of 2. So here also it is not a terminating. There is no question of number of digits in the decimal place, because the condition is that first must be terminating, then only we can say this decimal can be ended number of how many digits. So here we can't say this one gives the non-terminating repeating decimal. It gives, actually this number gives terminate. So according to this I can say that, but I haven't checked that one, first condition and the second condition also. If I can check, sometimes here you see by mistake if I can write like this, and there is common factors are there, 9 is the common factor here, so therefore if I can write non-terminating repeating decimal, so that is wrong. So it's the same thing I have done here, you see. So just looking at the denominator, prime factorization of the denominator, I said that this is not in the form of 2 to the power of n, 5 to the power of n, and therefore it gives non-terminating. It is not correct. We have to check that conditions. Okay. So now what are the conditions are there here? So that conditions we have to check. First condition is either that one in simplest form or not, the given rational number is in simplest form or not. So now I am going to check. This one is 9 ones are 9 and 9 eights are 9 eights are, so 72, and 0 9 twos are. Okay. So 9 is the common factor. 9 is the common factor, therefore we can write 802 upon 5 to the power of 2 to the power of 0. Now you can check, this is in the form of, this is in the means denominator. Denominator is in the form of 2 to the power of m, 5 to the power of n. Whenever this is in the 2 to the power of n, 5 to the power of n form, and it gives a terminating decimal. Terminating decimal. Next to fifth one. Whenever here also I can say that now after how many steps or how many decimal places this division will be ended. So here only the highest power is 2 is there. After 2 decimal places this division will be ended. So next here 143 upon 110. Is there any common factor for this? We have to see that. So 11 ones are 11, 11 threes are 11, ones are 0, 10, 13 upon 10. So here you can write 13 upon 2 to the power of 1, 5 to the power of 1. So this one also in the form of 2 to the power of m, 5 to the power of n. So it gives a terminating decimal. Terminating decimal. So how many decimal places are there in the terminating decimal? Means only one decimal place. How we know means we will check easily. This one is only one is there. So here 10 ones are 10, 30. So 3s are 30. So here you see how many decimal places are there in this decimal expansion. So only one digit is. So because the power of the 2's and 5's is equal to 1, so only the one digit is there in the decimal places.